Welcome to part 7 of Competency 15. In this video, we will work with box plots, standard deviations, and variance. And once again, using that TI-84 calculator. Okay, construct a box plot for the following set of 12 individual data and find the value of mu, which is the mean. Okay, since this is just a data list and not a table, all we need to do is enter that as is into our first list. I've already populated that into L1. Okay, so you see there, I'll show you, arrow up, there's the bottom. Okay, so now we go to stat, arrow over to calc, we need one var stat. Let's push enter. Okay, we are in L1, so we need to enter second one. Then for our frequency, clear that out and push enter until we get what we need. Okay, looks like the first thing that we see here is 17.5 is our mu or our mean. Okay, then naturally we have a median, a minimum, a max, and a median. I'm going to arrow down till all of it's visible. And see, n equals 12 tells me that we do have the proper 12 values entered. And then our minimum here is our 2. And our maximum is our 33. Then our Q1 is 7.5. Our median, or Q2, is 16.5. And our Q3 is 28.5. Now, we had done one in the prior video like this. It's the same thing. But notice how when we create our box plot, that's the point. We need to construct it. So we need to know where all this comes from. And we have this, the axis down here. We see the axis. And notice how we have 1, 2, and then you can count it. It's rather accurate, but let me show you how I did that. So second plot. Okay, I have everything populated into plot 1. As you can see, though, plot 1 is off. If you look at my calculator. So we're going to push enter. And then see where it's highlighting? I'm going to push enter. Now it's flipped over and it's on. Okay, so let's do zoom and 9. And notice I have 2 plots in there. Well, that's the second plot that we're going to look at. So go turn that off. Okay, so I can actually, there's a quicker way to turn it off than to keep going back to that. Just push your y equals. I'm going to go up, I'm going to go over, and I can turn it off right there. Okay, so we're actually done with this. Okay, so what we're going to do is go to number 2. Number 2, construct a box plot for the following set of 13 individual data and find the mean or mu. Okay, so what we have here is the exact same list, but we've added 20 at the end. Okay, so let's go ahead and go to our calculator and go to our list. Now I have put this over here in L7. I'm going to arrow up and show you. I added 20. Now, the reason that I have done that is so we can compare those 2 plots. Okay, that's the pink one that you saw earlier. So let's take a look at this. Okay, I am turning on my plot. All right, let's get out of that and go second. Oh, sorry, second and y equals. Now you see I have plot 1 and plot 2 on. And you can see just by looking that I have the first set of data was in L1. Remember, it's still there. And L7, we have this set of data. Okay, so let's go to zoom and 9 for our stat. Now see how close they are? Okay, as you see, the pink one is slightly different, but the rest of the data looks very much the same. Okay, so let's go second mode and let's go stat, arrow over to calc. We want 1 vars, but this time we want to put in L7. Remember, I put it in L7. Okay, so how do we do that? We say alpha L and then push 7. Okay, now why did I do that? Well, notice if you go to your numbers and you're looking in the blue, look at your, oh, I'm going to have to get rid of that. Okay, there we go. All right. So if you look at number 1, you have L1 in blue. You keep going, you have L4, L5, L6. When you get to 7, 8, 9, there is no L1, 2, 3. But if you remember looking at the list with me, that there were several columns, there are many in there where you can populate. So that's how you get it in. So let's push enter. And what our median is rounded, and it is 17.7. Okay, let's back at, well, no, let's not back out of that. Let's look at our difference first. Okay, so we have 2 again for our minimum. Our maximum is 33 again, but our Q1 is 7.5 again. Okay, this is where it changed. Our Q2 or our median is 17. That changes things. Our Q3 is still the same at 28.5. Okay? So let's look at both of the graphs on the, plotted together like we had earlier. Remember, I turned them both on. So zoom, push 9, and there they are. Notice right there in the middle, our medians are very slightly different. Notice for number 2, the pink, it is 1/2 greater. Okay, so that compares the two of them for you. Number 3, construct a box plot from the following grouped frequency distribution. Okay, again, unfortunately, we can't just put something in L1 and L2 or in a list and get what we need. We will have to do some calculating, okay? And the first thing we need to see is what our total frequency is, and that is 45. And first, we're going to divide that by 2, and that's going to equal 22.5. And then if we divide that by 4, we will get 11.25. Okay, and if you remember why I'm doing that, that's so I can look at which rows I'm actually working with and which class, uh, and how to manipulate my numbers. Okay, so if we start at the bottom, obviously we're going to, because this is 25 is our largest number. So in this case, I start from the bottom. And I need to go 2.25 up. Okay, let's see if I can write this. Oh, goodness. See if I can write this better. There we go. So we need 22.5 from the bottom to the top. Well, what does that mean? That means if I subtract 22.5 from 25, I am really using 2.5 out of the 25. I went from the bottom, but the honest truth is that all this is calculated from the top. For example, from the top down to a little bit here into our column with the 4, we see that that's our first 11.25, okay? Then from there, we go, that's 1, 2, oh, this is what's a little confusing, is we go down and we go into the the column with 25, that's 11.25. Well, that is halfway. This is where it's confusing. Okay, so the first 11.25 right here in this column with a 4, that is going to be, all we need to take out of that is 0.25 out of the 4. We just need a little quarter to get what we need. Well, why is that? Well, 6 plus 3 plus 2 is 11. And I need that amount to be 11.25 for my Q1. And that being said, my low value of my class, remember, we're capturing all the data. And the only way to capture that is to calculate a little half outside. Remember, sometimes in stats we do this. We're going to go maybe a half less or a half more. Okay, so that'll be our Q1. All right, so that's Q1, and that's going to equal 84.5, and we're going to add that to, oh, what's our class width? So our class width here is 5 all the way down. So that is 5 times 0.25 over the 4, because it's in the column with the 4. And then whatever estimated that is, that's what we're going to use. All right, I'm going to change colors here. Now we need to go down to the next one. Now this is where it gets a little confusing. When we go down 11.25, we're here. And then going down another 11.25, that is our median. That's halfway into our data. Okay, so that's barely our Q2. So that's Q2. And at the end of that column, we have 94.5. Okay, so that's 94.5. And we're going to add that to 5 times. Well, that's 25 is the row we're in, and we need 2.5, 2.5. So 2.5 over the 25, right? Then whatever that estimate is, okay? Now, for the Q3, we go down another 11.25 from where we were. So the issue is these values are all smushed in together on that row per se. So what is really going to happen? So what we're doing is we can take off 11 or add it, however you need to see it. What I did is I said 11.25 times 3. That means that I need 33.75 points, okay? So 33.75 points. However, how many points are down to here? How many data points are there? Okay, well, we have 10. Well, that's 20. So right here, that's 20. So I subtract the 20. So what do I really need to take out of that 25? Now, I'm not taking out, you know, I'm taking out some, but it's also including the 11.5. It's kind of confusing. That's why I do Q2 separate from Q3. Okay, I don't calculate them together. That may seem like that's what I'm doing. Okay, so what I really have here, when I subtract what I need, 33.75, which is 11.25, 3 times, that's 3/4 of the information. Okay, minus the 20, which is what we have up to all the rows. That means I need 13.75 more bits of that data. Okay, so then what is my Q3? What is it going to look like? So I have Q3 Q3 equals, again, I'm using 94.5. That's because I'm still in the last column. I don't change it. I use what I have. Okay. Then 5 times the 13.75. Oh, no. Yeah. Yes, 13.75. I'm sorry. Okay. Over the 25. And then whatever that is, that will be my Q3. Okay. And then if you look at this data, we're really not sure where the data is, what my low is, what my high is, but you could say from the class, okay, we could say we have potentially a minimum of 70 and potentially 99 as your maximum. But with this type of table, that's it could adjust a little. You don't know. We don't have the actual data in our hands. Okay. Now let's calculate Q1, Q2, and Q3. Okay, so 84.5 plus the parentheses 5 times 0.25 divided by 4, close parentheses, and we get 84. So I'm going to write that down here. Actually, we could even change color again. 84.81. Of course, we have to round, okay? Actually, we wouldn't even really, in this case, you could go without rounding because it looks like the value cuts off at 80.8125. Either way, we round it. Okay, now let's go for Q2. Okay, that is 94.5 plus in parentheses 5 times, and we have 2.5 divided by 25, close the parentheses, and we have 95. Okay, we have a whole number. It happens sometimes. Okay, so now again for Q3, we start with 94.5 and we add our parentheses 5 times. Now our fraction this time is 13.75. And again, divided by 25 and close parentheses. And that would be, and look, we don't really have to round here either. This would be 97.25, 97 and a fourth. Okay, great. Well, that wasn't too bad. If you memorize how you find these values, okay? I would stop the video, go over it again for yourself and see if you can mimic what I've done. Right. Okay, now it's asking us, what is the IQR? Well, we see what that is. I'm going to highlight the box here. Inside this box, what is that? Well, we subtract Q3 minus Q1. You know what? I'll write that down. Again, Q3 minus Q1. What does that equal? Well, let's just put it in the calculator. I'm going to go up and grab it. Okay, well, this is our Q3. Q3 minus, and go up and grab our Q1 and push enter. Okay, I have roughly, well, if you round, that would be option B, 12.44. We could go without rounding, and that's a perfectly good number. Okay, let's move on. Number 4, construct a box plot for the following grouped frequency distribution. Okay, this is very much like what we did in the last problem, problem 3. Okay, again, we cannot just use L1, L2, a list, and get what we need. We will have to calculate this. Okay, so I begin by looking at my total. Well, the total is 60 data points, and we divide that by 4. That gives us sections of 15. Okay, so the first section of 15 data points will be right here in the first row. That means I need 15 of those out of the 19. And my lower end of my class on that row will be 19.5. Again, we have to do that so we capture all the data. We include everything. Okay, then the next 15, it will be on the next row. Well, I know that I need 11 out of the 14 because the first row we used 15, we had 4 left over. Take the 4 plus another 11. 11 gives me that 15. Okay? So that's Q1, Q2. Oh, at the end of that row, we do need that lower end of the data class. So that's 33.5. Okay, now we need to capture our next 15 data points. So that will go all the way into the fourth row. So let's see here. I had 3 left from row 2 and 9. That'll be 12. That's on the next row. Then we need 3 more out of the 7 to make Q3. Okay, and at the end of that row, we need to capture with our low of 61.5. Okay, so let's set all those up and we'll put them in our calculator. Okay, so Q1, and we have Q2 and Q3. So Q1 is 1905. Well, goodness. Okay, there we go. Okay, let's try that again. 19.5. I don't know if that's any better. Plus, okay, our class width for these classes is 14. So we have 14 times the 15, 15 over 19. Okay, and then the next one, Q2 is 33.5 plus 14 times 11 over 14. Yes, we could cancel this, but I'm just going to type it in the calculator as is, okay? Yeah, just in case. Okay, so 61.5 is our last low for Q3 plus 14 times the 3 out of 7. Okay, we'll just type all 3 of those into the calculator and we can write that on our box plot. Okay, let's see here. We have 19.5. Add that to the parentheses of 14 times 15 divided by the 19, close our parentheses, and that is 30.55. So yes, that is correct. I mean 33. Wait a minute, 33 or 30? Nope, I was right the first time. I looked over at columnized posts. That is not correct. It is 30.5. Okay, now let's look here. What would our low be? Well, actually, we could say that it's that 20, but really we're estimating. We don't know. We don't have the data. All we have is a table created for the data. We can say a lot about it, but we cannot guarantee that we know the low and the high. We can estimate them. So we could even, just say, well, we think that the high is 115 degrees. Is it? Who knows? Good enough. Okay, so what's our Q2? That is 33.5 plus the 14 times, and that is 11 divided by 14 closed. Did I type that incorrect? Yes, I did. Push enter, and that Q2 or median is 44.5. 61.5. Okay, now let's do Q3. 61.5 plus parentheses 14 times 3 divided by 7, close parentheses, 67.5. And that is correct. So we have 67.5. Okay. Okay. Now I do want to also point something else out. If you notice how this has actually been created in our TI-84, let me show it to you. Well, actually, I can't show it to you because this is an estimate. And what I really had to do, I mean, I could, I suppose, show it to you, but what I had to do is estimate. And this is why our x-axis is so misleading. Okay, that it isn't accurate. Now, to really make this work, you would have to use an online program. So, in order to get this to look in this way, again, let me state that I had to estimate on my calculator. So, there's no way without just a list of data to get what we need. We are just using what we have with the formulas that we know to get the best we can. Like we can't guarantee uh, this axis to be correct, and we can't guarantee the minimum and the maximum. Okay, let's go to number 5. Okay, what is the sample? That's important. Sample variance, S squared, and the standard deviation of our lower sigma for the following data set. Now, this is a list of data. This is where we can guarantee our findings. Okay, so what are we going to do? We already have this populated. Let's go to Stat, highlight on our edit. There's our list. Our list, that's the exact numbers. However, our list has been sorted. We used it prior and I left it there. And let's make sure that the last number, see, and we don't have that added 20. Remember, I put that in L7. So our L1 is still good. So what do? We push stat, arrow over. We're still going to use number 1, our 1 bar stat. Push enter, enter. We're in L1. That's great. Enter again. And there we go. An arrow down so we see all of the data. That's what we had before. Now, what are we using? Here's the thing. Look at what your calculator has. Do not make the mistake of using the population versus what we don't. Population is what we don't want. I circled the word sample. We are looking at the sample. This is a sample of data. That tells me that we need the SX. That's the item we're using. And that will be 11.23. That means option D and A will not be what we need. Now, we need S2. Okay, let me show you how to get that very quickly without having to, write it, type in and estimate it. Let's not do that. We need vars, go to 5 stats. Okay, arrow down to your SX. Okay, that's our sample deviation. Okay, sample standard deviation. Okay, now push enter, push the X squared to square it, enter again. This is the value that we need, and that will be option B. Okay. Number 6, what is the sample variance S squared and the standard deviation of S? Notice they changed the letter on you again. This is one of those situations we just have to know how to read our calculator. Okay, for this data, okay, we need 5 13s, 2 21s, 1 33, and 7 of the 40s. I have that in a list, or you can put it in a list for yourself. Push stat, enter. Where do I have it? I'm going to arrow over and see where I put that. Oh, maybe I haven't. And it's not in there. Okay, thought I had it. Well, let's put it in. It's not there. Let's do it for ourselves. Okay, so we need 5 13s. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I need two 21s. 21, enter. 21, enter. 133, 33, and 7 40s. There's 1, 2, 3, 4, 5, 6, and 7. Let's go back and count those again. 1, 2, 3, 4, 5, 6, 7. Great. Okay. All right. So we should have a total of how many items entered? Let's see. We have 13, 14, 15. Okay. So that's 7, 8, 9, 10. Yep, 15. That's what we have. All right. And we put this all in. Let's make a note of this. It is in L2. Okay. All right. All right. Let's go to stat. Remember how to do this. We go stat, calc, and number one's what we want. And we need to say that it's all put into L2. Nothing in the frequency list, just our list of numbers. Okay. So we need to look for, remember, this is SX sample because it says sample. Okay, so the value we need is right here. It's 12.69 or 7. So there's our 69, 12.69. Okay, they did not round it. Well, they rounded a little, but not all the way. Okay. All right. The second decimal point. Okay, we are rounded. We are good. Now, what do we need to do? Okay, we need to push bars, number 5, go down to our SX, push enter, and then push our X squared and enter again. And that's our value. And option D is what we need. Okay, now let's look at what we have for number 7. Same thing, but they're going to give us a frequency table. Okay, in this situation, we can populate a list for this. So what we need to do is find the middle values. Okay, and the class width is 5. So since the class width is 5, we will literally start with 5 and count by 5s. 5, 10, 15, 20, and 25. How do I know that? Well, if you literally put your fingers up, you can say 1, 2, 3, 4, 5. The middle number will be 3. Okay? Well, all right. But if we start with 3, 3, 4, 5, then 6 and 7. Okay, so we had a width of 5. We want the middle number every single time. And then what happens is since the class width is 5, you're just adding on 5 each time. Okay? All right. So let's see if I have that entered already. I may not. I do not know. Okay, so counting by 5s. And I do not see it. So let's enter it. We can go ahead and put it. I'm thinking we need to, yes, I need L4 and L4 and L5. Might want to erase things out just in case we need to come back to it. So why don't we put it in, let's say 6 and 7. Yeah, let's do that. 6 and 7. We haven't done that. Let's show how to do uh, the larger value, the larger numbers, L1, L7, L8. Let's do an example with that. So let's go up. We can just clear that out. Great. Now let's count by 5s. 5 entered, 10, 5, 10, 15, 20, 25. Okay, great. Now arrow over. Oh, let's see, that was L6. So we were using L7, but we don't need it anymore. So let's clear that out. And let's use that. 1, enter, 3, enter, 9, enter, 5, enter, and 2, enter. Okay, so now we have that set up. What do? Same thing we did before. Go to stat, arrow over, we need calc 1. Okay, but however, remember, we put these in L6 and L7. Okay, I'm going to go back and double check that. All right. See, L6, L7. Okay, calc over, enter. Okay, so we need second 6. That gives us L6, but L7, we can't do it that way. We have to say alpha and go here to this last comma where you see the L, and that gives us your L, and then just push the number 7. Okay, I know it looks different, but it really is what we need to do. Okay, push enter, enter again, and there's our information. Okay, and as we can see, for SX, our standard deviation for our sample, here, they're rounding. So that tells us that these two items will not be used, C and D. So now we have to figure out which one of A and B we need. Great, let's go to VARs. Number 5, arrow down, push enter, x squared, so we're squaring it, push enter, and it is 25.6. A is the correct option. Okay. Okay, for this last problem, we're doing the exact same thing, precisely the way we did it before, but we do need to discuss our class width. Well, the class width is 5. Okay, and once again, if we lay that out, that'll be 58, 59, 60, 61, 62. 60 will be our middle number. Okay, so we say 60, 65, 70, 75, 80, and 85. Okay, and we put those in a list. I do believe I already have those entered. We saw them earlier. Yes. So in this case, we're using L4 and L5. So that's L4 and L5. Okay. So we say stat, arrow over. Once again, we're using number 1. 1 bars, 1 var stat, enter. Okay, and now we need to change that to second number, go back, second 4. There it is. And we enter, and then second number 5, enter, enter. Okay, and looks like for our deviation, we need 7.07. Okay, and again, these last two items will not be used. Okay, so we go to get our squared, remember vars, 5, arrow down to number 3, or just push number 3, either one. I'll just push 3. There you go. And then square it and enter, and F is our correct option with our variance, 49.93. Actually, that should be 4. They trunk it. They did a trunket instead of rounding. Either way, it's our closest. When you're doing A, B, C, D multiple guess, you just do the best option. Okay. And this is our last question. Once again, please, could you share us, like us, and if you haven't subscribed, please do so to keep these things coming for free. Thank you and happy testing.